Assalamu alaikum students, this is Sir Abdul Samad Khan and today we are going to learn the final topics from the chapter of sets for grade 9 and 10 matriculation. So let's get started. Cartesian coordinate system for a plane. Okay, as we see that we have given a graph and this graph is actually divided into 4 equal parts by drawing these two axes. The vertical axis is actually known as the y-axis and the horizontal axis is actually known as the x-axis. Second thing is that the upper part of the y-axis is to record the positive readings, so it is known as the positive y-axis, and the lower part is to record the negative readings, so it is known as the negative y-axis. Similarly, the right hand side of the x-axis is to record the positive readings, so it is known as the positive x-axis, and the left hand side of the x-axis is to record the negative readings, so it is known as the negative x-axis. The third thing is we have to mark the quadrants like first, second, third and fourth. So you have to remember the sequence, just to remember like to move in the anti-clockwise direction like this. Okay, this one is the first one, this is the second one, this is the third one, and this is the fourth one. The other thing is that over here x is positive and y is also positive. It means in the whole first quadrant all the order pairs when are plotted when the value of x and y should be positive. Over here x is negative and y is positive. That means in the second quadrant all the order pairs will be plotted when the value of x is positive and y is when the value of x is negative and y is positive. Okay, in the third one x is also negative, y is also negative. It means that whenever both the values of x and y will be negative, it will always be plotted in the third quadrant. And the fourth one, the value of y is positive, the value of x is positive and the value of y is negative. Whenever this condition applies, that kind of order pairs will always be plotted in the fourth quadrant. Okay, where x and y are called the Cartesian coordinates of the point P, x is called the x coordinate or the axis of P, and y is called the y coordinate or the coordinate of P. Now let us learn this with the help of some examples. Example number 1. Find in which quadrant or axis the following order pair lies. Now over here we have given an order pair 2 and 3, and as we see that both the values are positive, and you have to remember one thing is in every order pair the first value will be considered as x and the second value will always be considered as y. So in this case both the values are positive, and we have already seen in the previous slide that whenever both the values are positive, it will always be plotted in the first quadrant. Okay, second one. Over here x is negative and y is positive. Whenever x is negative and y is positive, such kind of order pairs will always be plotted in the second quadrant. Third one is when both the values are negative, x is negative and y is also negative, such kind of order pairs will always be plotted in the third quadrant. And the fourth one is when x is positive and y is negative, such kind of all the order pairs will always be plotted in the fourth quadrant. Okay, we have 3 other examples as well when that order pairs will never be plotted in any of the 4 quadrants. Like if in this example we have -2 and 0. Okay, so if any of the value amongst x and y is 0, if any of the value is 0, you just have to remember that none of these kind of order pairs will be plotted in the first or the second or the third or the fourth. These kind of order pairs will always be plotted on any axis, on an x-axis or an y-axis. So if we want to learn that on which axis this point will be plotted, you just have to remember that which value is given, x or y. The answer is x, so this order pair will be plotted on the x-axis. Okay, the sixth one is in this case x is 0 and y is given, so the answer is this order pair will always be plotted on the y-axis. And the last one is when both the values are 0, so it will always be plotted on that point where both the axes meet. Okay, and this is known as the xy axis or the origin. Okay, domain and range. What are the domain and range in the set? the set of all of the first elements of all ordered pairs in a relation R from A to B is called the domain of the relation R. The set of the second elements of all the ordered pairs in the relation is called the range of the relation. Domain of relation is denoted by dom R, and range of relation is denoted by range R. For example, let A contains the elements x, y and z and B contains the elements 1, 2 and 5. Let us take a following relation. Okay, now we have a relation of x1, x2, y1 and y2, and we have to ask to find out the domain and range from it. And we know that domain is actually the first value of every ordered pair, and we see that the first value of every ordered pair is actually xy. So the domain in this case is actually xy, and range is actually the second value of every ordered pair, and in this case the range is 1, 2. So the range of this relation is 1, 2. Simple. Okay, definition of function. What is a function in set? Let A and B be any two sets and R be a binary relation from A to B. Then R is called a function from A to B if. If means if the following two conditions apply, then the relation will become a function. The first condition is when the domain of any relation will be equal to A, that means that we will be equal to the first set. Domain means the first value of every ordered pair of any relation. Okay. Second condition, every element of A is associated with exactly one element of B under that relation. Condition 2, that means this one, implies that R contains no two pairs having the same first element. Now let us learn this with the help of an example. Example number 2. Okay, let A contains the elements x, y and z, and B contains the elements 1, 2 and 3, and we have given the relation x1, y2 and z3. Over here, domain of this relation is x, y and z. Domain means the first value. Okay, x, y and z. That means the domain of this relation is x, y, z, and it is actually the value which is in the set A. Okay, the first value verifies, and every element of A is associated with exactly one element of B. That means every element of this set is making a pair with every element of this set. That means x1, y2 and z3. Okay. As R means relation, as R satisfies the conditions 1 and 2, therefore R is a function from A to B. If a relation is a function, then it is usually denoted as f. If f is a function from A to B, it is written as like this. F is a function from A to B. Okay, types of functions. First type of a function is called the onto function. What is an onto function? A function f from A to B is called an onto function if range of that function is equal to B. Range means the second value of every ordered pair in the relation. Okay. For example, let me take the set like set A with the elements x, y and z, and in the set B we have the elements 1 and 2, and the relation which is actually the function, we'll take x1, y1 and z2. So over here, if we just look at this, the first value is actually the domain, which is the first condition of any function. So x, y and z is actually the domain in this case, and it is really actually the set A. So first value, first condition verifies, number 1, and number 2, for the onto function, the range of that function will be equal to B. Range means the second value. If we see over here, 1 and 2 are the second values, and 1 and 2 is the range in this case, and 1 and 2 is actually the elements of set B. That means both the conditions verifies. Okay, if we just draw a diagram to show this relation or a function, it means x is moving towards 1, y is always also moving towards 1, and z is moving towards 2. That means 1 is the image of x, 1 is also an image of y, and 2 is the image of z. Here range of the function is 1 2, which is actually equal to b, as I've already told you before. Therefore f or a function is an onto function. Number 2, 1 1 function. What is a 1 1 function? A function f from a to b is said to be 1 1 function if distinct elements of set A is associated with the distinct elements of set B. Distinct means different. For example, if we take set A with the elements x, y and z and set B with the elements 1 2 3 and 4, and then we take the relation which is actually a function of x3 y1 and z2. You can also make the different one as well. So in this case, if you see that the first value of every ordered pair is actually the domain, which is x, y and z, okay, and domain should always be related to the first set, that is A, and it is verified over here, number 1. And number 2, every element of A differentially will make the pair with the element of B. So if we see, first element x is making a pair with the one element 3, and the second element of set A, y, is actually making a pair with the second element, that is 1, and the third element of set A is actually making the third pair, which is the 2. So in all these three cases, all these three numbers, these alphabets are making the pair with the distinct objects. So if we just draw the diagram of this function, x is moving towards 3, y is moving towards 1, and z is moving towards 2. That means 3 is the image of x, 1 is the image of y, and 2 is the image of z. Here 1 is the image of y, 2 is the image of z, and 3 is the image of x, as I've already told you. Here any image is not associated with 2 or more elements of A. So this function is a 1 1 function. Okay, the third condition is 1 1 and onto function. 1 1 and onto function is a function f from A to B is called a 1 1 and onto function if it is both 1 1 and onto. For example, let me take set A with the elements x, y and z, and set B with the elements 1 2 and 3, and we are going to take the relation which is actually a function x2 y1 and z3. Okay, in this case, if we see that both the condition of the 1 1 function and the onto function applies. Okay, the first value of every ordered pair is actually the domain, which is x, y and z, number 1, and number 2, the second value is actually the range, which is the condition of the onto function. If we see, the second value of every ordered pair is 1 2 and 3, and 1 2 and 3 is actually the elements of set B. That means the first condition of the 1 1 function also apply over here, and the second condition of the onto function apply over here. So whenever the function which contains both the condition of 1 1 function and onto function, that is called the 1 1 and the onto function. Okay, if we draw the diagram for this relation, it will be like somehow like this. So x is moving towards 2, y is moving towards 1, and z is moving towards 3. That means 2 is the image of x, 1 is the image of y, and 3 is the image of z. And hence it implies the both. Therefore function f is 1 1 and onto function. So that's all from today's video. Inshallah, we'll meet you in the next lecture with the new chapter. So till the next time, thank you so much for watching, and Allah Hafiz.